You know, right under our feet, completely hidden from view, there is this secret world. Today, we're going to dive into how fungi build something scientists have nicknamed the Wood Wide Web.
It all kicks off with this incredible idea that beneath the quiet, peaceful surface of a forest, there's a buzzing, high-speed communication network, a biological internet made of fungus. Think about that for a second.
I mean, it sounds like something straight out of a fantasy novel, doesn't it? But here's the thing. This isn't fiction. Trees are communicating, they're sharing resources, they're even helping each other out. So the big question is, how on earth are they doing it?
To answer that, you can't just guess. You need evidence. So let's head into the forest, where researchers first started to uncover this secret language. Okay, so picture this. You've got scientists out in a dense European beech forest. They're trying to see if there's any truth to this wild idea of a connected ecosystem. So they set up this experiment to track where resources were going, and what they found? Well, it completely changed how we understand forests. Forever. The results were just crystal clear. They watched carbon, literally the building block of life, flowing from the big, mature trees over to the young, vulnerable saplings. But here's the kicker. This was happening even when their roots weren't physically touching. The connection, the bridge that was delivering all this aid, it was mycelium. This was it. This was the proof that trees could cooperate.
So, okay, seeing it happen is one thing, but how does it actually work? What's the science behind it all? Let's get into the nitty-gritty and unpack how this Wood Wide Web is built.
So the official scientific term for this thing is a mycorrhizal network, and what it really is a partnership. It's a symbiotic relationship between fungi and the roots of plants. This huge web of fungal threads connects individual plants, sometimes across massive areas of a forest.
And it is a perfect two-way street. The plants, they do their photosynthesis thing, creating sugars and carbon, which is basically food that they feed to the fungi. And in return, the fungi act like this massive root extension, exploring the soil, mining for essential nutrients and water, and delivering them right back to the tree. It's a classic win-win.
So if the mycelium is the network, then the hyphae, they're like the fiber optic cables. We're talking about these incredibly tiny, microscopic threads that branch out and connect with each other, forming the actual physical pathways that carry all this information and all these resources.
I love this analogy because it's just so perfect. These hyphae aren't just sitting there. They are dynamic, living highways, absolutely bustling with traffic, moving goods and information exactly where they need to go throughout the entire forest community.
And the traffic on these highways is incredibly diverse. You've got the basics, of course, nutrients and water, but it gets so much more sophisticated. The network can send chemical warning signals about, say, an insect attack, which lets the neighboring trees put up their defenses. It also smartly sends more resources to the seedlings that are struggling in the shade, which makes the whole forest stronger.
Now, like any complex network, think of our own internet, it's not just a chaotic free-for-all. There are nodes that are way more important than others, central hubs that manage a huge amount of the traffic.
And scientists call these hubs mother trees. These are generally the biggest, oldest trees in the forest, and they can be connected to hundreds of other trees all around them. They are the superconnectors of the network.
And their role is just absolutely critical. These mother trees, they don't hoard all the good stuff for themselves, no way. They actively nurture the next generation, pumping vital nutrients to the little seedlings growing in their shade. It's this beautiful system that ensures the survival of the whole community.
This is all mind-blowing science, right? But the question is, what do we do with this knowledge? How can understanding this incredible network actually help us, grow a better world?
While the applications are incredibly practical, for foresters trying to regrow a forest, this is a game changer. They can plant new trees strategically near existing mother trees to help them tap into the network and boost their survival rates. And for us, in our own gardens, we can encourage these networks just by adding organic stuff like wood chips and leaves, which fungi absolutely love. It's all about working with nature to build healthier systems.
So let's just step back for a final thought on this incredible world that exists just beneath the surface, completely out of sight. The next time you walk through a forest, just remember you're not just walking over dirt and roots. You are walking on top of nature's hidden internet, a complex, thriving web of life, communication, and collaboration.
Ultimately, I think the Wood Wide Web teaches us this really powerful lesson. We often think of nature as this constant, fierce competition, survival of the fittest, right? But this
This reveals a much deeper truth, that life often thrives best through connection and helping each other out.
And that leaves us with one last big question. If a system this complex, this intelligent, has been operating right under our noses for millions of years, what other wonders, what other secrets are we still missing, right beneath our feet?